Hello, I welcome you to this video where we want to discuss the concepts of earth geometry. Looking at the question here, it says, in the diagram, A, B, C, and D are points on the surface of the earth. A, B, C, and D are points on the surface of the earth. Take pi as 3.142 and r equal to 3,437 nautical miles. So this is the diagram being referred to in the question with the points A, B, C, D. The first part of the question says calculate the length of the circle of latitude 52 degrees north. The length of the circle of latitude 52 degrees north. Second part, calculate the distance BC along the longitude 76 degrees east. And part 3, calculate the distance DC along the circle of latitude 78 degrees south. Okay, so before we can go into the calculations, it's important to understand that on the surface of the earth, we have got these special lines that we need to understand in the name of latitudes running from west to east. And then we also have the longitudes running from north to south. So these are special lines that makes up what we have here on the surface of the earth. And when we talk of the latitudes, which are also known as the parallels, these make what is known as the small circles. Latitudes make the small circles except for one which passes through the center of the earth at 0 degrees, which is known as the equator. So that is for the parallels or the latitude lines. They make small circles except for the one passing at the equator at 0 degrees. Now for the longitudes from north to south, they form what is known as great circles. So we need to understand the two types of circles that are formed on the surface of the earth using one, the latitudes, and then also the longitudes. So getting back to the question, it says calculate the length of the circle of latitude 52 degrees north. The length of the circle of latitude 52 degrees north. Now, talking of the length of the circle of latitude 52 degrees, how can we calculate the length of the circle of latitude 52 degrees? Okay, so when we talk of calculation of length of the circle, we are simply talking about the perimeter of the circle, or the total distance around the circle, which in this case, it is the small circle that we are considering. And for that, we are going to get the formula for length of the circle. So we are saying length, that is for the first part, length is equal to 2 pi r, okay? Then cos theta. The theta in this case represents the latitude where this circle is based. So this is the formula that we are going to use to calculate the length of the circle. And from here, we are going to simply get the information that has been given here and substitute into the very formula. So we are saying length is equal to, so we say 2 multiplied by the pi has been given as 3.142 times the radius, which is in nautical miles, has been given as 3,437, then multiplied by cos theta. In our case, the theta is being represented by the latitude of 52 degrees. So this is what we are supposed to do. So remember, this is about length. So we continue. We can just get these numbers and multiply. So let me just do the calculations from my end. We have 2 multiply 3.142 by 3437. So this is going to give us 21,598.108, which shall now multiply cos 52 degrees is going to give us 0.6157. We can end at that. And then length is equal to, so we can multiply everything. And from my end, we are going to have 13,000, sorry, 297 point, okay, 0.1. Okay, so length, approximately length is going to be 13,297 nautical miles. So this is how we are going to find the solution to the first part of the question, which was talking about the calculation for length of the circle at this latitude. So important to understand is the formula that you can use to calculate the length of the circle, which is simply 2 pi r cos the latitude where the circle is based, in case you are dealing with a small circle, like in the question that we have here. We can quickly move our attention to the second part, which talks about calculation of the distance BC along the longitude 76 degrees east. So we need to understand that for distance BC, okay, BC is part of the great circle that we have here. So for the great circle, we understand that the formula that we can use is going to be theta over 360 degrees, okay, multiplied by 2 pi r, okay? So why theta over 360 degrees? Because when we look at BC, BC is a part of this complete circle for the great circle that we have here, okay? So because it is a part, we can say it is a fraction of the entire great circle. So that's why we're saying it is going to be theta over 360 degrees multiply 2 pi r, which is the total length of the circle. So what are we going to put for the theta in this case? So we understand that the 2 points that we are considering for B and C are at different latitudes. B is at 52 degrees, then C is at 78 degrees. So to find the value of theta, we get the difference between the latitudes for B and C. And how do we get the difference between these latitudes? Because they are from the different points or different sides of the equator. This one is north, the other one is south. We are going to add these numbers for 52 and for 78. I'm going to repeat. So I'm saying because these latitudes are based on different hemispheres, to get the value for theta, we simply supposed to add. So in our case, we are saying theta, okay, is equal to, so we add 52 degrees plus 78, which is going to give us 130 degrees, okay? So this is the value for theta, the difference in latitudes, okay? We can continue. So BC, we are saying BC is equal to, so we get the 130 degrees divided by 360 degrees times 2 times 3.142 times the radius, which is 3437 in nautical miles. So we can simply now punch these numbers on the calculator and we should be able to get the value for the distance BC. So from my end, when we punch 130 degrees divided by 160 degrees, sorry, 360 degrees, times 2 times 3.142. It's going to give us, so I'm getting the final solutions, okay? So this is going to give us 7,800 nautical miles. So what we have gotten here, again, we need to understand that this is an approximated value for BC, the distance BC. That is for the second part of the question. Moving to the last part, it says, calculate the distance DC along the circle of latitude 78 degrees. So the second one was distance along the longitude, which is a great circle. The other one is talking about distance DC, which is along a small circle of latitude 78 degrees. So the formula that we are going to use will be a little bit different from what we had used on the second part of the question, but the concept remains the same. So we are saying DC is also a part of this complete circle. Because it's a part, then we can say for solution on number 3, we are saying DC is equal to, so it will be theta over 360 degrees times 2 pi r cos alpha. Okay, so the alpha is coming about because this is now in the small circle of latitude 78 degrees. So the alpha is going to be the latitude where this distance BC is based. So our alpha, we are saying alpha is equal to 78 degrees. Then our theta is going to be the difference in longitudes. For the second part, our theta was the difference in latitudes, okay, for B and C. Now for DC, our theta is going to be the difference in longitudes. So we have the longitude at D is 43 degrees west. At C, it is 76 degrees east. So again, these are on opposite sides, the west and the east. Because of that, we are supposed to simply add these numbers to get the value of theta. So our theta again is going to be 43 degrees plus 76 degrees. Okay. So when we add the two, we are going to get, let me just, okay. So this is going to give us 119 degrees. This is the value for theta. This is the value for alpha, which we are now supposed to substitute into the formula that we have here for distance along a small circle. So this one we are saying is the formula to use for distance within a great circle. Then this formula is for distance along small circle. So we need to understand the distinction between the two. This one, great circle. This one, small circle. So let's continue and just substitute into its formula and see what we are going to obtain. So we are saying DC is equal to, so what is our theta? We are saying it's 119 degrees over 360 degrees times 2 times 3.142 for pi times the radius we have in nautical miles is 3437. Then cos, our alpha is 78. So we are saying cos 78 degrees. Okay, so we continue. So this is going to be, so this is 78, okay. So this is going to be, DC is equal to, so again, let's just punch these numbers on the calculator and see what it's going to give us. So from my end, we are going to have DC approximately. It's going to be 1,484 nautical miles. Again, these numbers have been given to a value which is an approximate. So approximately DC is going to be 1,484 nautical miles. So these values can vary on how you round off the numbers, slightly maybe higher or lower than what we have obtained here. But important to understand is that we are trying to calculate distance along small circle. As long as the distance is within some latitude, then you understand that it's supposed to be you're supposed to use the formula that we have used here for small circles, except for the one which is at 0 degrees or within the line of the equator. That one, you use the formula for the great circle. So that's it for this part of the question. And just to test your understanding, you can try out this question here, which is similar to the one that we have just handled here. So you can pause the video and then try out this question and see how you can best handle it. Thank you. I'll see you in the next one.